Well, another Monday morning is here. Today we're going to be talking a little bit about battery drains, parasitic drains, whatever you want to call them. These things are about as old as vehicles, and it's just really irritating, and sometimes parasitic drains can be hard to find. You're not going to find all the answers here, but we're going to hit the highlights of it, and I give you a little bit of a benefit from what I've learned over the years. So let's just get started on this thing right now. Now, battery's kind of like a reservoir of electricity. The electrons in the battery want to be on just one side of the plates. So when they get all the way to the side to where they want to be, the battery's dead. In other words, you can say that current flow is from positive to negative, electron versus whatever. So basically, let's just say that the electrons want to go to the negative side of the plates. Let's just say that, because you can't see them anyway. Okay, so once the electrons are all on the negative side of the plate, then no more work can be done because they're all where they want to be. But if you pump them all over onto the other side of the plate in the battery, they have a strong desire to go back to the negative side of the plate, and if you provide a path, they'll do that. And if you put a load in there, like a bulb or a motor or whatever, then work can be done. And so that's really basic on that. So we're going to turn the battery on its side so that the ground is on the bottom. The English call this earth, by the way. And so let's say each chamber is perfectly sealed, so no power can move unless there's a connection between the plus and the minus side. These are the big posts or the terminals that you're going to see on the battery. That's basically how it works. So when you charge a battery, the electrons want to go where they'd rather be. We talked about that a minute ago. When we charge it, we're forcing them to go where they don't want to. Imagine yourself pumping water into a tank, and then gravity feeds out of that tank. See, it's going to stay in the tank until there is some path it can take to leave the tank and follow gravity to where it wants to go. Okay, and so think about your windmill in this picture here that I created being your battery charger. So whenever you're releasing the provide a path, the load is gonna be like this water wheel, and work is being done whenever you're pouring that water across the water wheel. It's going to the ground. Of course, there's always got to be the windmill or the battery charger, whatever, refills the battery or the tank, if you will, and provides the differential that's necessary to get this work done. Now, some electronic components have capacitors that are like little reservoirs that store electrons for later release. The condenser in a distributor is a capacitor, and you can actually lay that thing on the engine block and let the spark plug wire pop to it. It'll store that voltage in that condenser. Everybody that's ever played a joke on another mechanic, back in the day whenever cars had points and condenser, you let that thing pop, and then if somebody's going to pick it up, if they touch the can and the terminal end of that wire at the same time, it finds a path through them and it knocks the tar out of them. Now, as far as I know, there's not anything dangerous about using a little condenser. Now, if you got these great big ones, like you see in air conditioning units and all, those are big old capacitors, and they'll knock your hand off, so don't play with this stuff. But these little capacitors here, like you see, are going to be in these modules, and whenever you first hook the battery up, those capacitors, a whole bunch of them and a whole bunch of different modules have to charge up, and it takes a while for that to happen. So that's going to show up as a battery drain that's only temporary and that's normal. Okay, so we have seen, when I was working at filling station back in the mid-70s, sometimes Farmer Brown would take his battery that was dead, and he would accidentally, I'm talking about just stone dead, and there's nothing there, and he would accidentally hook his trickle charger up to it backwards, with the negative to the positive and positive to the negative, and he would charge the battery up backwards. That's doable, believe it or not. Imagine how that would destroy some of the electronics on a car today to have a battery charged up backwards. But anyway, it's charged up backwards. He'd bring it in there whenever he realized he had done what he had done, wouldn't work right. And we would, at the filling station, we would hook a light bulb up, like you see here. You saw my little animation there. So we would leave that light bulb on until that light bulb completely burned all the way down. We let all the electrons go to where they wanted to go. And then we would charge it back up the right way, which is something that we would do. A lot of people don't even know you can charge your battery up backwards, but I know it from personal experience, and we used to see that sometimes. Well, so when is a battery dead? Well, according to GM, using about 40% of the total amp hours will usually take a fully charged battery to a no start condition at moderate temperatures of 77 degrees Fahrenheit. Another way, a typical battery in a storage situation depleting the available amp hours by 20 to 30 amp hours will result in a no start. It won't be enough to spin the engine over because the starter is what's going to need all that power. So AH refers to amp hours. Most folks, mechanics too, like to refer to the cold cranking amps. That's the big deal now. Years ago, nobody talked about cold cranking amps, but now they do. And it's good. You can buy from Harbor Freight a cheap little machine, handheld tester to test for cold cranking amps. It's a little bit annoying to use, but I bought one just to play with, and then I gave it away. But in other words, it'll tell you how many cold cranking amps the battery has left. Now, I was talking about it being a reservoir of energy a while ago. What it amounts to is, as when you first, and I've mentioned this before, when you first buy a battery, let's say it's got 850 cold cranking amps. Well, if you check it a year later, it'll probably have 750 or something. And every year it's going to lose about 100 cold cranking amps on the average. That's been my experience. And if you keep that thing 6 or 7 years, it's going to be down to the point where it will barely tell. It'll barely start the car. Now, what you can do, if you can disable the fuel and the ignition system, well, you can actually just disable the fuel system really, and get that thing where it'll spin over, and say won't start, because you don't want it squirting fuel in there. So just killing the coil is not going to do this. So what you're going to do is have it where you can spin it over. And you can push the gas pedal all the way to the floor. On a lot of vehicles, it will be in clear flood mode. The only problem with that is if it's got any gas puddled up in the intake somewhere, it may start up and try to run away. So you'll have to be ready to take your foot off the gas really fast. But if you push the gas pedal all the way down, on a lot of different platforms, it will turn the injectors completely off, and you can spin that thing over and see how it spins. Now, if you got a voltmeter connected so that you can read the system voltage while you're spinning this thing over, you can watch your watch, spin it for 15 seconds on your timer, have a little timer, and after that spinning for 15 seconds, if it goes below 9.6 volts, then it's not good enough for that car. It really needs to be replaced. If it stays above 9.6 volts, it'll be okay for a while longer for that vehicle, which is just a basic rule of thumb. Now, whenever you did it with a carbon pile tester, like we used to use at the shop, you would actually go to half the cold cranking amps rating, whatever that was, and you would dial it up to that, with your tester telling you how much of a current load you were putting on it with your carbon pile, turn that knob, and it would basically, if it stayed above 9.6 volts in a 15-second load at half the cold cranking amps, then it passed that particular test. There's a lot of other tests you can do on a battery, but that's just a basic rule of thumb. But cold cranking amps is the deal nowadays, and that's what people typically look at. And whenever I'm testing it with I've got a tester here, the really nice Autel tester that costs several $100s that I like to test my batteries with. And I may demonstrate that on a later video because there's a lot of stuff that tester will do. It's pretty cool. Okay, amp hours and cranking amps are two different measurements. A 120 amp hour battery can deliver 1 amp for 120 hours, or 2 amps for 60, or 3 amps for 40, or 4 amps for 30. You get that? So cranking amps is the number of amps a lead acid battery can deliver for 30 seconds at a temperature of 32 degrees Fahrenheit and maintain at least 1.2 volts per cell. So if it stays above 7.2 volts, then that's about how many cranking amps you got, the number of amps. How many amps can it continue to deliver for 30 seconds? That's the whole point. While maintaining those voltages. Voltage and amps are two different things, Voltage is your pressure, and amps is how much flow you got. We might do another presentation on that later, but that's just basically the way it is. All right, so the reserve capacity is the number of minutes. Charge battery at 80 degrees will discharge 25 amps until the battery drops below 10.5 volts, right? Okay, so if losing 40% of the amp hours would kill this battery below the point to start the car, you can see how a parasitic drain, even a small one, might be an issue. Typically, if you've got the coil closed on a relay, even if the relay is not pulling a load, one of the things I figured out is that's enough that over 2 days it'll kill a fairly strong battery. Not a really strong battery, but if it's got a mediocre battery in it, doesn't need to be replaced, but it's not fresh and new either, you'll kill it in a couple of days by energizing a relay coil. And of course there's going to be probably some load by the points that are, whatever the relay is pulling is going to affect the timing on that. Some electronic modules on newer model vehicles in late 2000 and up have capacitors that need to charge up when the battery is first connected. A capacitor is like a little battery that stores a charge, but only for a few seconds. It does take a little while for all the capacitors in the various modules to fire up. And so keep that in mind before you start yanking fuses. If you find a draw when you hook your meter in series right to start with, whoop, I've got a draw, and don't start pulling fuses right then. I'll talk more about that again in just a minute. Here's your generic layout. You got your battery there, and you got your underhood fuse box, and you got your underdash fuse box, you got your module groups. Typically, the underhood fuse box will have some larger fuses. It'll have smaller ones too. But whenever you find which small fuses the large fuses are pulling, I start by pulling these big fuses, the maxi fuses, while watching my current, or watching sometimes I'll use an oscilloscope and I'll have a little inductive, current trace that's going on the screen, and you can watch that, and when you got a draw, it'll be above zero, if you zero your probe before you put it around the wire. And so whenever you pull out the one that zeroes it out, the scope will tell you exactly how much is being pulled by each load. Sometimes you'll have two different fuses pulling two different loads, and you may think you got it when you didn't. We used to use a test light years ago, hook a test light up in series. That's not very reliable. I mean, it kind of works, and we did it for years. But if you on these more complicated cars, you can be misled by using a test light to see if there's current leaving the battery, right? So anyway, if you find, let's say, if you pull this one fuse, and that one fuse kills the thing, and then you find out that thing feeds 3 or 4 smaller fuses, you got to put the big one back in and keep testing, pulling the small ones one at a time. So finding the drain means eliminating circuits that aren't drawing current. So when you had the battery disconnected, you inserted your meter, you had to allow the capacitors in the modules time to charge up. This can take about an hour. Okay, so connect your meter to read amps and then go to work. All right, you home in on the draw like this. When you've removed the big fuse that feeds the smaller fuses and you've seen it drop off, focus on the smaller fuses and it will lead you to the module or the circuit or whatever is the source of the parasitic draw. That typically works pretty good. Now you can use one of these meters here. Now don't use a meter that you buy from Harbor Freight. Harbor Freight meters are okay, these inductive current testers. If you get one that reads AC volts but won't read DC, and that's what you're going to find over there for $13, you're going to need one that'll read either DC or AC volts, because you're going to be reading DC volts, not AC. You hook this thing up so the arrow is pointing away from the battery on the negative side. Remember that. The battery is going to be pointing away from the battery. I mean, the arrow on the tool is going to be pointing away from the battery, because that's what the current flow is based on what the tool manufacturer did. More than 50 milliamps is too much, and you need to find out what's going on. The positive cable is harder to probe on a lot of times than the negative cable, because sometimes you may have several different positive leads going off, and it's hard to isolate, those where you can get this clamp around them. But I've got one of these things, and I really, really like it. The one that I've got was made by General Technologies up in Canada. Now, we use this in series. You can hook your meter in series like this, but you got to put it on there with alligator clips and whatnot so it'll stay. You don't want to have to hold it the whole time. So you put it on there. Still, more than 50 milliamps is too much. So we were having this 2010 Mustang, and we put that thing on there, and it had a pretty good size draw, like 1 or 2 amps or whatever. And the students got all excited about going to finance. I said, no, let's don't do this. Let's walk away and just leave it sitting out here with this meter hooked up and this current flowing. Doors are closed, keys off and out of the ignition. Everything's, dark, or supposed to be. And so after we walked away for an hour, we came back and all of the current draw was gone, and the meter was still hooked up really good. And so it turned out on that one, the battery was killing itself. Now that doesn't happen a lot, but it can. One time I drove my 2006 Explorer down to the place where I taught classes about 25 miles south of here. I'd go down there in the morning and teach, and then I would go over to the other place where the college campus where I taught. And I told my students, I said, we're going to change the oil on my Explorer today, so go ahead, and I had pulled it up there and parked it when I went in there to start my day, and I says, bring it up on that drive-on lift, and we're going to change oil in it. And one of them came back in and said, what's the trick? I said, what are you talking about, what's the trick? He said, well, I can't even get a light to burn on the dash. I said, what in the world did you, I drove that thing up there and parked it not 20 minutes ago, went out there, turned on the key, it was like it had no battery in it. And this was a Motorcraft battery, which are usually pretty good, and that's usually what I buy. Opened the hood, battery was there, it was hooked up, but it was like there was no battery there at all. There was no power in that battery, period. Now, always wear safety glasses when you're working around batteries, because batteries can blow up, and you don't want a blowing up battery to be the last thing you ever saw. So it's a whole lot better off, even when you're just jumping a car off. I know you got away with it a lot of times, but it's always a good idea to wear eye protection. Don't dodge that, and don't feel like you've cheated somebody and went ha 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 because you got away with jumping cars off for all these years without wearing, safety glasses or whatever. Anyway, that's one of these things. We let all the capacitors charge up on all the modules on that 2010 Mustang. Turned out that the battery itself was a problem. We could have done a whole lot of work if we weren't patient and if we didn't walk away and just wait. See, and that's what you need to do. Now, you may need to drive a vehicle and operate all the options during the test drive, then turn it off, wait for all the modules to go to sleep. Whenever we do it that way, I like to use the inductive clamp around the negative battery terminal. Point it with an arrow. If you point the arrow toward the battery on the negative side, you're going to get a plus reading instead of a minus reading and all that, and that's going to be, incorrect. You can still get the numbers, but the plus or the minus before the numbers on the meter is an issue. But all of these modules and everything, they're going to pull a little bit of juice, Now, one way you can also do it, my friend Pete at Motor Age teaches this with whenever he does his Motor Age training. You can take a meter and you can measure voltage drop across each one of the fuses. And you're not disturbing anything this way, although you will see down here at the bottom on these, they have taken the little covers off of those fuses there. That's something that's got to be done, and that can be annoying. But once you get it in there where you can check the voltage drop across the fuse, then you can get a pretty good idea what the if one of them has got more than the others, then that's a suspect connection. Now this is just one of many ways that people do this kind of thing. But you're going to set it to the lowest millivolt scale and put the test leads across the fuse, see if you're dropping any voltage there. Now, if you got to keep the door of a vehicle open to gain access to an interior fuse panel, and by the way, remember, some of the fuse panels are under the back seat, some of the fuse panels are in the trunk. Some vehicles will have fuse panels on the left and on the right, or on the left and under the seat. And GM cars are like that, and some of your other cars are too. Make doggone sure you know where all the fuse panels are. Some of the Chrysler, Dodge Chargers and stuff, like an 08 Dodge Charger's got a fuse panel in the trunk and all that. So make sure you know where all the fuse panels are. Start with your main. If you look at a lot of these totally integrated power modules, won't have very many of your big fuses. Sometimes the power module itself will be a problem, but don't throw that on there first, because you may wind up spending money you don't need to spend. Yeah. Anyway, so thermal imaging. Watch this video I just made this morning on my wife's pickup truck. All right, now. All right, watch this thermal imaging. I overlaid the thermal imaging. See the warm relays? Those warm relays are the ones that are actually got current flowing through them. Now, interestingly enough, on this particular vehicle, that's not abnormal, but if you leave that vehicle parked too long, you can see how it would kill the battery. Her battery has never been dead from sitting, and we don't drive that truck a lot. It's a 2016 model. It doesn't have a lot of miles on it, and it may sit there a week, sometimes 2 weeks, but we've never once had to jump this vehicle off. However, it's got just a little whisper of current going through these two relays. So you can, just because you've seen a warm relay with your forward-looking infrared camera, doesn't mean there's a problem there. You see what I mean? Because this truck hadn't been started since Sunday when we drove it to church. So just be aware of the fact that you don't want to get a false positive and go off in the wrong direction. You're basically going to need to gather a library of skills by chasing a lot of parasitic drains, and you'll get better at it. You're going to see vehicles with this issue if you work on cars. Get used to it, get good at it, Parasitic drains are often the radio. I don't know how many times I've seen bad radios cause this. This one guy brought his 2019. Well, he was at a tire store belonging to a friend of mine. They called me over there, and I took my, that tool I was talking about earlier, and his battery would go dead about every other day, and so I didn't spend a lot of time fooling with it, because I did check and find out he had an issue with the battery, so he went ahead and put a battery in it, but. It turned out, I told him to take it over to the Ford dealership and let this guy work on it over there that I knew that was really good, because I didn't have time to, at the time, to spend a lot of time chasing this guy's problem. It turned out that he had made his own problem when he put a trailer tow package on it, the little trailer brake connector under the dash and all this stuff. The trailer brake connector under the dash was what was causing the problem because of the way he had wired that up. So he couldn't hardly blame it on the truck. He actually caused himself a problem. Now, any module on today's network intensive vehicles can be a battery killer, and relays can stick and cause the batteries to die and all that. So they're just I could go on and on about this. This is a little short video. It's going to be about 22 minutes long. So I hope you guys have a great week, and thank you for watching, and I appreciate you sharing my videos with other people and giving me likes and comments, and I'll talk to you next time around.